Okay, in this video we're going to talk about addition formulas. This is still section 1.2. So let's get to it. Problem 16, part A, determine the next most probable equation in the list. So I've got a list of equations. We're going to determine the next one. So let me just verify that each one of these is correct. 1 equal 1, the 2's cancel there, that's true. 3 equals 3, the 2's cancel. 6 is equal to 12 divided by 2 is 6, that's true. 10 is equal to 20 divided by 2, that's true. Okay, so based upon this list here, we want to predict the next equation. Well, it looks like on the left side, we are adding the next counting number on the list. So I'd want 1 plus 2 plus 3 plus 4 plus 5 equals, and then whatever that last counting number is, that one, and then the next one up is going to be on the numerator on the right side, and then you're always going to be dividing by 2 on the right side. Okay, so I was just ending at 5, so we want 5 times 6 divided by 2. 5 times 6 is 30, divided by 2 is 15. If you add these 5 numbers together, you also get 15. Okay. Part B is where I want to determine a formula in terms of n based on the pattern from part A. Verify that is correct when n is 100, and then find the sum when n is 175. Okay, so if I come up with a formula representing what I'm doing here, it looks like I'm adding a bunch of counting numbers. So let me say 1 plus 2 plus 3 plus 4 plus all up to n. N is some counting number. And it looks like, from the pattern, I see I'm just going to take that counting number, whatever the last one is, times the next one up, and then divide it by 2. Okay, so n is where I'm ending, times the next one after that is n plus 1, divided by 2. Now, if you recall, Gauss's problem, which was the problem that we did in the last video here, we had the same problem here that I gave you, and so Gauss was really using this formula when he computed, okay, which is kind of neat. So if you take 1 plus 2 plus 3 plus 4 plus all the way up to 100, okay, using this formula, n is 100, n plus 1 is 101, okay, divided by 2, 100 divided by 2 is 50, and 50 times 101 gives you 5,050, okay? So, as an example, what if we take 1 plus 2 plus 3 plus 4 plus all the way up to 175, and we want to know that sum? Well, using this formula that we just computed, we take the last number, which is 175, times the next one after that, 176, and then divided by 2. Okay, and I should be getting 15,400. And if you check that using the calculator here, that's what we get. Okay, so Gauss was really using this form. Now he wasn't doing the problem like this, where he was just using a formula. He was using the first and last terms. Now remember, he was doing 1 plus 100 is 101, 2 and 99 is 101. Okay, so how many times do you get 101 would be 50. Okay. Since 50 times 50 plus 101, or 50 plus 51 gives you 101, so 50 times 101 gives you 5,050. Okay, it's much quicker to multiply rather than add 100 numbers directly. Okay. Problem 17 is where I want to determine the most probable next term in the list. So same thing. Let me just verify that these equations are correct. So I got 1 equal 1. 1 plus 2 cubed, 2 times 2 times 2 is 8. So 1 plus 8 is 9. 3 squared is also 9. 1 plus 8 plus 27 gives you 36. Okay, and if I take 6 squared, I also get 36. 1 plus 8 plus 27 plus 4 cubed, 4 times 4 times 4 is 64. That gives me 100. Okay, and if I take 10 squared, I also get 100. Okay, so based upon what we see here, what would be the next equation? Well, if I take 1 cubed plus 2 cubed plus 3 cubed plus 4, so it looks like I'm just adding the next counting number, which would be 5, and then cubed. That should be 1 plus 2 plus 3 plus 4 plus 5 squared. And again, let me verify that that is correct. 1 plus 8 plus 27 plus 64 plus 5 cubed, 5 times 5 times 5 is 125. So if I take 100 plus 125, I get 225. And over here, 1 plus 2 plus 3 plus 4 plus 5 is 15. 15 squared, 15 times 15, should also give you 225. Okay, so that is true. Now of course, one thing that I want to do here, whenever I'm determining the next most probable equation, we were doing a little bit of this in the last section, is of course make sure that your answer is correct. Okay, so you don't want to 225 equals some other number. Okay, because that obviously is not correct. Let's take a look at part B. We want to determine a formula in terms of n based upon the part from A, and then find the sum for when n is 50. Okay, so based on what I see here in part A, what would be just a general formula representing what's going on? Well, it looks like I'm adding up a bunch of cubes. So if I take 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus all the way up to n cubed, n is some number, then that would be equal to 1 plus 2 plus 3 plus 4 plus all the way up to n squared. Okay, at least based on these equations here. Now, remember, the nice thing about inductive reasoning is that the conclusion may or may not be true. Okay, we don't care about that. We're just trying to come up with an equation that represents what's going on based upon this list here. Okay. So if I find the sum for when n is 50 using this formula, I got 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus all the way up to 50 cubed. Okay, well, that would be equal to, using this formula, 1 plus 2 plus 3 plus 4 plus all up to 50 squared. Okay, now 1 plus 2 plus 3 plus 4 plus all up to 50 would be a time-consuming thing if I were to type that in all into the calculator. So maybe I can use inductive reasoning here and see a pattern that's going on. If I take 1 plus 50, I get 51. 2 and 49 is 51. 3 and 48 is 51. So every single time I'm going to get 51. Now, the question is, how many times do you get 51? Well, if you work your way towards the center, the last two numbers that you'd use would be 25 and 26, which when added would give you 51. Okay, so there's going to be 25 times that you would get 51. Okay, so obviously it's going to be faster to multiply rather than add directly. Okay, so if we take 25 times 51 squared, 25 times 51 squared, I'm getting 1,275, okay, and then squared gives me 1,625,625, okay, which would be correct. Okay, so the idea here is to try to observe a pattern based upon these initial equations, come up with an equation that represents what's going on with the pattern, and then use that equation to predict a term, what if n is 175? Okay, what if n is anything? Okay, well, the nice thing about n being anything is that we can know right away. Like if n is, 223. Okay, well, I take 223 times 224 divided by 2, boom, I'm done. Okay, so rather than adding directly all those numbers. Okay, so very handy to use. Okay, and we'll go ahead and stop right there.